Hey, what is up guys? So in this video, we are going to go ahead and make some animations in Blender, but we are going to use this Python API and we're going to have the help of ChatGPT. So without further ado, let's jump into it. In this particular video, what we are going to make is we're going to make a simulation of colliding balls, okay? So a very popular simulation. But I'm not gonna do any homework beforehand. I haven't written up any code or done any of that. Okay, so I have Blender open on my right and I have ChatGPT open on my left. And the very first thing we're going to do is we're just going to ask ChatGPT, how can I generate a single... now it's very important how we word our question. I know I'm new to Blender, but I know that when you create solids, for example, what you actually create is what we call meshes. So, and then we select which type of mesh. And I know for a ball it's probably gonna be an icosphere. So, what I'm gonna ask here is how can I generate a single icosphere in Blender using Python? And let's see what ChatGPT gives us. So boop 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 boop. It is generating. Okay, so the very first thing I like to do is before even trying to go into it, I want to see if it even works. Okay, so ChatGPT is actually giving me something that works or not. So let's take this code, Control C, and let's actually in our workspace, let's add another tab, and then we are going to turn this into the text editor because we want to write Python code. And on the bottom, I'm gonna pull this up. I'm gonna make this a Python console. So for example, if you want to test things line by line, we can test them directly in the Python console. And the last but not least, I'm going to open another, and this is going to be our, you might have guessed it. Sorry, you might have guessed it. This is going to be our info, and it's going to tell us what we're, like the output of what we're, I guess, making. So create a new page and then paste that code. And let's see if it even works. First of all, I'm going to delete all of this. So you can do this, or actually you can press A to select all, then delete to delete it. So that's gone. And let's run this. So slide over, see the run, and lo and behold, it actually generated a ball. So that actually worked. So what I'm going to do is I'm going to turn this into a function. Define create ball. Actually, no, actually, I'm actually not going to do that yet. I want to color this ball. So actually what I'm going to ask is, I'm going to follow up with ChatGPT and say, give this ball a color. Okay, let's see what it's doing. Okay. All right. So it seems what it is doing, it is first it is actually, I guess, creating the ball, set the scene units, it's renaming it to the name that you want to specify. And then I believe here it's set the origin of the object to its center, it's moving it to a location. And okay, this is a code of interest because it seems like this stuff is what we already did before. That's what it seems like. So the new code is probably going to be this stuff. This is where it's actually adding a material. So let's add this section and see what happens. Take it and paste it. All right. So let's take this out for now. By the way, I actually don't want to keep each time we run this. You probably may have noticed. Actually, you know what? Let's for a moment. Let's for a moment comment this out. Let's run this again. If you keep running this, you notice it just generates another ball. You do this many times. See, it keeps running duplicates. So we don't want these duplicates piling up. So what I should probably do is each time we run this, we should probably delete the previous mesh. So somewhere here on the top, delete previous meshes. Okay, so let's go ahead and do that. Let's ask ChatGPT, how can I delete all meshes in Blender using Python? Okay, seems pretty straightforward. It's pretty simple, 2-3 lines. Let's see if it works. Clean up deleted objects, update the scene. Let's see if it works. All right. Take this over and then put this in the beginning. Now press A to select all of these, delete all of them, and let's say, for example, let's say if you were to run it once. Oh, it generated an error. Scene object has no attribute update. Scene object has no attribute update. Let's ignore this for a second. Okay, now let's try it. Okay, that worked. But see how we generated one? Now let's try running again. See if it deletes the previous and generates it again. Oh, look, see? It deleted the previous and generated again. So we don't have it pile up. So it worked, and that's good. So what I'll probably do is I'll turn this into a function, define clear meshes, because we want to clear all existing meshes. Put this right here and take this out. So that is out. And I'm actually going to make this a little bigger because I want to be able to see my code more. Okay. So now in Python, those of you who are, familiar with Python, you know that it's good practice that whenever you're writing a module or a script, you actually want to run the script by sort of doing it like this, writing this routine that if name equals main. Now I'm not going to go into the details behind this because that's not really important. Just for the purpose of this video, just follow along with me. You can Google it and figure out why we do this, but it is a common practice to actually run the stuff that you want to run, the sequence of code that you want to run. So the stuff you want to build in your module could be on the top, but the stuff you actually want to run is on the bottom. So for example, let's say you want to run the sequence clear meshes. So it's going to be in here. Okay. So now each time we run this, it's actually just going to run what's underneath here. So let's do that. Wait, what happened? Oh, syntax error. It's supposed to be a semicolon. My bad. Oh, now it's working. Clear meshes. Now what we're going to do is so we went on a small tangent. Let's go back to adding the color. Okay, so let's add color. Uncomment this. And let's see how the color will look like. So right now we have material, it's adding a new material. And then it's adding a color, but I think it's using nodes. And what is it doing next? So inputs color default. What color is this? I do not know. So it's saying that this is actually RGB values are 0 to 1. And I guess this is RGBA format. So I'm guessing this is RGBA. I don't know. Well, I guess we'll find out. So I'm going to go ahead and just ignore this fourth value with the first three. Let's make it red, because I know red is 1, 0, 0. So this is a color that I can work with because I know what it looks like. So let's make it red and let's see if it works. What happened? Oh, because I didn't actually, see? Because I didn't put it in the sequence. So let's actually define this. Define create ball. And in this, what we want to do is some common parameters that we actually want to put it as arguments of the function. So for example, name and then color. We want to put these as the arguments. Okay. Should we care about radius right now? Is there anything about radius in all this? Yeah, there is. Radius is here and subdivisions is here. I imagine subdivisions is how fine the icosphere gets. I imagine that's what it is, but we can test that in a bit. So let's put radius. Let's put subdivisions. Now let's take this out. Let's make this subdivisions. Let me format this a little better so we can kind of see everything. So let's make this radius. Okay. So I'm not doing anything special. I'm just parameterizing things. So you can access arguments directly and turn this into name. Cool. Now, do we care about material name so much? No. Actually, what we'll do is we'll do something clever. Actually, not so clever, but we'll just say name plus material. So that way, we have original name plus material added to it. What else do we need? So we had the color. So let's go all the way to the bottom, and then let's put color here. And I'm actually going to now keep in mind, I think it's taking a tuple of 4 values, where I'm assuming the first 3 are RGB. So that's what we're gonna keep in mind here. Tuple of 4 values. We're gonna keep that in mind. Okay, keep that in mind. And so put this right here. Color. Cool. What else? Before we go ahead and run this. Oh yeah, location. This is move the object to order. This is where we want the location to be. So this is gonna be. We should probably include this as well. Location. This is going to be a tuple of 3 values. The XYZ coordinates. 3 values, x, y, z. Let's go ahead and put that there. Location. And let's see if this is actually going to work. Let's try running this. So what do we call this function? Define create ball. Oh yeah, we first have to shift or tab all this because Python indentation is important. Cool. So let's call it, what was it called again? Yeah, create ball. Let's call it create ball. And the values that we want to pass were these. Let's put them here. Okay, so what name do we want to give it? So we'll call it just ball. Color, remember this has to be 4 values. We'll say 1, 0, 0, and the last one was 1. So we'll just leave it at that. Radius, let's give it a radius of 2. Let's keep it at origin. Cool. And then from there, what can we do? Oh yeah, subdivisions. Default was 3. So let's see if this works. Let's just see if this works. So let's go ahead and run this. Oh, it did work. But why is it not showing the color? Because we are in, we're not in the shader mode, I guess. So I think the way you do this is, so here it's saying viewport shading, and here it's saying method to display objects in, oh, this is material preview. You probably see that. And this is wireframe. So this is wireframe. Okay, so this is kind of like a quick Blender walkthrough. So this is wireframe. This is solid, so you see it as a solid. And this is material. So now if you click material, oh, see, now it's working. It's red. Cool. Now what is this? This is rendered. Oh, we'll worry about that later. So yeah, if you want to see how your color is actually showing, then go to materials preview. Now I think down here is how you actually check. So yeah, here is how you actually check the material properties. So notice how all these diffuse BSDF, how I'm seeing all these terms BSDF. It seems like that's what it's doing behind the scenes. So we sort of just automated all this process in Python with the help of ChatGPT. Isn't that quite impressive? Seems simple, but it's a stepping stone. All right, so we build one ball. Okay, let's try building many. Let's see how that will look like. So what I would probably do is I would create a for loop. I say for location and color. Okay, so we're gonna have location and we're gonna have color. And in zip, by the way, so for those of you who don't know, zip in Python is for, let's say if you want to iterate through 2 lists or iterables of the same length, you can iterate through them together by using zip. So for example, location would be the iterated element from the locations list tuple or whatever, and color would be the iterable element from that list tuple or whatever. Okay, and we're gonna see this. Watch. So we have the list of colors. And let's say we want to make it. Now I'm actually not gonna go ahead and try to, or just write out numbers, because for colors like 1 0 0 0 1, because that doesn't really like give you any sense of what the color is. So what I actually ended up doing is I want to see what is a common list of tables of colors we can look up. So common list of tables of colors. Let's see. List of colors, AF. All right, so these are some common colors, but I want them in RGB, like I want them in values between 0 and 1, not in percentages. So let's see what we can find. Common list of colors. This is something I actually clicked. I don't remember when, but I remember this was useful. Let's see what we can find. Oh, this is actually what I need, because look at this. So these all range from 0 to 255. All we have to do is divide 255 and that normalizes it. So we have our values from 0 to 1. So I'm not going to bore you in the process. I'm not going to belabor you in the process of converting these to tuples or like arrays. So I'm going to quickly do that and I'm going to get back to you. Alright guys, so I'm back. So I actually went ahead and took this giant list and converted it into a dictionary of all those color values, those same color values. And each value of each key of each color is a size 3 numpy array with the values between 0 and 1. And this is what we want. And I could have very well put this as tuples, but I put this as a numpy array for some reasons that aren't important right now. Okay. So that's why I imported NumPy. So actually, let's get to extracting some colors. So for example, we can work with, let's say we generate 10 balls and we want to generate, we is this a typo? Yeah, that's a typo. Let's say we want to generate 10 balls and we want to generate magenta, silver, maroon, common colors, purple. So we should be able to see them. So I'm going to create a list of ball colors. Okay, so the common ones are going to be red, green, and then I'm going to go through the rest. Okay, so these are our 10 colors: red, green, violet, white, magenta, blue, teal, beige, purple, and indigo. Now let's go ahead and generate our coordinates, the locations for our 10 balls. So I'm going to kind of keep this a little straightforward. I don't want to have too many weird locations. What I can actually do instead, you know what, instead of hard coding locations, what I can actually do is I can create a random generator of locations. Yeah, that's actually probably smarter. Let's do that. Let's create a random generator of locations. The way we can do that is, I know in Python that how can we, or let's ask ChatGPT, generate a number, a random number between 0 and 1 in Python. Okay, there. That's all I needed. Import random, random.number. So let's import random on top. Cool. And what we're going to do is we're going to say that let's say that our locations is an empty list. It's an empty list for now. And then we say for let's say for the value doesn't matter, in range 10, since we're going to generate 10 random locations, we say that the x coordinate is a random value, random dot random. The y is a random value, random dot random. And same for the z, random dot random. Okay. Now I want to have, now there's a range. Obviously we don't just want the x and y's and z's to be 0 and 1. There's a certain range that we want them to be between. So how we do this is we scale things. So let's specify a scalar s. So let's say we want to have it between 0 and 100. So our scale factor would be s, and we just scale this. S times this, s times this, and s times this. Now what we do is we say locations dot append. We add to that list the tuple x, y, and z, and these are going to be our locations. So we have our ball colors and we have our locations. Cool. Now let's take all this out. Let's actually just take this out as well. Have ball colors and locations. And now you can see what I sort of meant earlier, that zip, it helps you iterate through multiple lists of the same length at once. So location is an element of, sorry, this is flipped. My bad. Location is the element of locations, color is the element of ball colors, okay? So for our location color in this, let's actually generate our ball. So now our color, remember our color is a string, but we actually want it in this size for a tuple. So what we actually should probably do is, remember, up here is we had a dictionary of colors. And the key value, if you specify a key in colors for a dictionary, you get the value. So that's what we essentially want. So going back down, our actual color, so I'll say color underscore is equal to colors, that string value color that we got, and then we yeah, that's what it is. And then from there we split it up into its coordinates. So we say now we could do by index, like color 0, color 1, color 2, but a faster way to do it is through unpacking. So we can actually unpack this and then take these two out. And what unpacking will do is unpack those three elements in the size 3 numpy array. It'll unpack 1, 2, 3. Okay. So going back down, we'll get the RGB unpacked, and we have the 1. And for name, so I want to actually put a counter here, I equals 0. And then each time we iterate through this, the counter will go up. And for our name, we'll have ball plus a string, so we know which number ball it is. Cool. So put that right there. Now let's see if this will actually work. Oh wait, yes, sorry, we have to put the location there too. So location is going to be here. Now let's run this. It actually worked. Wow. So we're seeing a bunch of balls scattered. Now I feel like the scale is a little bit too high, so let's make it smaller. Let's make it 10. See what this does. Oh yeah, so now they're more smushed together. They're actually overlapping each other. I don't want that. Let's make it 50. Let's make it 50. Okay, this seems reasonable. This seems like something that we can work with. Now, the very next step is, now that we're generating a bunch of random balls, okay? Now the very next step is, actually, you know what I want to do is, instead of hard coding colors, I actually want to randomly generate colors too. The reason why I want to do this is so it gives me freedom to define how many balls I can define. So right now we're strictly only stuck with 10, but let's say I want to define 15, 20. I don't want to keep defining a color every time. So what I'll probably do is I'll create a random generator for this. Why not just ask ChatGPT directly that extract a value from dictionary, or sorry, extract a value from dictionary at random. Okay. Choice list my dict values. Okay, so this is what we should have done. I don't know why I went through that tangent, but it's okay, you know. It's trial and error. You figure it out. Let's try this. Import random.choice. So now what we're going to do is, this is going to give us the actual value of our color. So put that here. And it's not my dict. For our case, it is colors. And so now going back to here, we actually don't need to do this, because what we get is our numpy array, and we're going to unpack that. Because remember, we're not getting the key, we're getting the value of our dictionary. The value is at size 3 numpy array, so we unpack it directly. Now let's try running it. So we have ball colors, we have, cool, we have, so we can take this out. We don't need this anymore. So right now n is 10. Let's run this. Name colors not defined. Did you mean colors? Did I not define this? Oh, let's make this like this. Cool. See, now it's generating random colors, which is what I want. Run it again. See, each time different colors, different location of balls. So far it's working. Now let's up the count to, let's say we want 100 balls. See what it does. Cool. Now we have a little pile of 100 balls, and we can keep doing this, and it'll be different colors every time. That is cool. Also, why is it picking mostly the lighter colors? That is strange. I don't know why it's doing that. You know what? Let's not focus on that right now. So we're able to generate any number of balls. We're able to scale it. Let's say if we scale it to 100. We're just, the scale meaning how much space these balls are, their locations are, the range of the locations. So now it's more spaced, because you have a range that can spread from a range of 0 to 100, 0 to 100, and 0 to 100, x, y, z. So more spaced. Now the very next step is I'm going to do is now we're actually starting to move things up a notch. Okay, now it's actually starting to get a little trickier. So now we were able to define the ball. We were able to give it a color. We were able to define many of them at random locations with random colors. Now the next step is, how can we get these balls to move? How can we animate this? So what I'm going to actually ask is, first I'm going to ask is, how can I move a ball from one, actually sorry, how can I move a ball from a, how can I move a, you know what, I'll generalize this. How can I move a mesh from start location to an end location in Blender using Python? Let's see what it gives us. So this is the start location, and this is the end location. Total frames is 50. So by example, I was saying 50 frames. An increment. Now, before we actually copy and paste this, let's try to see what this is actually doing. Now, what this is doing is, what I imagine is this keyframe insert is what I imagine is actually creating the change in the animation. Okay. And I think what is happening is between the keyframes is interpolating the position. So to kind of see this, let's copy this. Let's see what it does. Let's copy it. All right. Did you create a random mesh just to see what he created? Context offset frame start location increment. But where's our mesh? BPO object. Actually, you know what? How can I move? How can I move? Let's say, how can I move a ball? Yeah, see, so first he's creating the ball, okay? And then he's doing the same thing that I think I explained earlier. He's adding a keyframe for each frame in these 50 frames. So 50 frames, iterating through all 50 frames, creating a keyframe. And what I imagine is, let's say you have a start position and you have an end position, and it's for each frame, it's interpolating those positions, and that's where it's setting the keyframe. But I think that when it comes to keyframes, I don't think you have to, because here what we have is we just have a straight path. For example, right? Let's take a look at, like, for example, this single ball right here. This ball is gonna move like a straight path like this, right? And let's say it's going to end here. It's going to start here and it's going to end here. We don't care about. I think that when you have a straight linear path, you only need to set a keyframe at the start and at the end. You don't need to set a keyframe at every single frame in between. Like, you don't need to set a keyframe for the position here, for the position here, for the position here, for the position here. So this seems kind of time consuming. So I'm gonna ask ChatGPT that, why don't you only add keyframes at start and end. Now let's see if it's doing the same thing. Aha! Look, see, that is much more simpler. So here we had a ugly for loop, and we're adding a keyframe between each frame. But here, we're only adding a keyframe at the start location, and we're having a keyframe at the end location. And what you'll actually find, I'm not going to demonstrate this because we don't have all the time in the world. But this is maybe an exercise for you, that this will actually, when we have a linear motion, this will actually give the same result as this, but this is much more efficient. So let's go ahead and take this, and let's reorganize it so it's based on our own code. So I'm going to actually create a function called define create moving ball. Okay. And what I'm going to specify is I'm going to specify a start frame, an end frame, start location, and an end location. Now I'm actually going to call this function, because to create the moving ball, first you have to create the ball, right? Then we can move it. So what I'm actually going to do is I'm going to take this function, I'm going to embed it inside this function. So all the inputs of this function will also be the inputs of the other function. So take these inputs and put it as the inputs of these function. Okay. So now the very first thing we can do is take this. All right, so we're just repassing those. The next thing I want to do is I want to take this code and put it here. Let's indent it, because remember, indentation is important. Our start location and our end location is actually start location. Let's have similar, the way it's typed. Let's make it similar. Put this right here. Take this out because we're specifying it. And from there, he's creating the ball object. He's creating the ball object, but we already created it, so we don't need to recreate it again. Take this out. Actually, hold up. Ball object. Okay, so before we can change things, what we first have to do is we kind of have to have access to the ball. So one thing we can do is, if you go back up here when we're creating the ball, is see how it's creating the object, and here how we have the same thing, BPY context object. So what we can do is we can actually return the object here, return object, and now we can say that ball is a return of this function. Ball is a return of this, and then we can take both these lines out. So now all we have to do is call this, or actually let's call this ball object for consistency. Okay. So now what we have the ball object and we're creating the ball and now we're going to move it. So based on our start location, keyframe insert data pad location index equals -1. What is this stuff? Start frame. But how do you actually frame set? Okay, frame set 50. So set the frame to the desired end frame. And I imagine it would be something similar for the desired start frame. So let's take this code and let's put it here for the start frame. So let's copy the start frame, put it here. Let's take the end frame and put it here. Okay. Okay. Now I think we're getting somewhere. So, let's actually go ahead and modify our code a bit. So here we're creating a ball, but now let's create a moving ball. So let's take this, Control C. Let's say moving ball. And now what I'm gonna do is all the inputs that were here, name, color, radius, subdivisions, take those and put those down here. And now the start location, end location. Now this is where it's important. Start location and end location. Now, for the start and end, what we can do is we can also generate random locations. Yeah, we can do that. We can generate random locations. But actually, you know what? Ball object dot location and start location. You know what? We actually don't need to. Now that I think about it, we actually don't need to specify the start location because start location was already defined when you're creating the location. So we can actually take this out. Actually, you know what? I think we can take both of this out. We can take this whole keyframe out, no? No, actually, no, we might need it. So let's just comment this out. So we're just basically just adding an empty keyframe. All right, so we're commenting the start location. We don't need this. I don't think we need it for now. I'm just gonna comment it for now. So the start location, take this out. And it's just location. Now what we're gonna do is, so you know how we have locations? Let's call this is just locations, right? Now let's create another one called end locations. End locations. And we're going to do the same exact procedure for the end locations. We're going to do X, Y, Z. And we're going to do end locations. All right, so end locations, the same procedure. End location, same procedure as locations, where we're just generating at random. So let's put that there. Let's specify a third one, end location, and then end. Okay, let's see if this works. Hopefully it works. Hopefully it does. We have to specify an end frame. So our start frame, let's just make it, for now, let's just make it 10. And then for end frame, let's make it 50. Or actually, let's make it 100. Why not? Let's run this. Sorry, let's run this. Invalid index, line 232. What will happen? Oh, silly error. Let's run this. Invalid syntax. 301. I keep forgetting those commas, man. What now? Line 306. See, all these silly syntax errors are coming up. This is all part of the fun. I think now it's actually running. But I'll see it generate everything. Now, if you take this, right? Look at the timeline. Frame 100, frame 10. It added keyframes. See this? We just added 2 keyframes. Now, this is the discussion I was having earlier, that if we went ahead and did this approach, where we're adding a keyframe for each single frame, you see these yellow diamonds, you see them everywhere for every frame. And that would be very inefficient. We wouldn't want that, especially for something that has a very linear motion. So, see how all these are moving? They're all scattering and random. And that is exactly what we wanted. But my question is, why aren't all of them moving? Only some of them are moving. That's odd. Why aren't all of them moving? That's interesting. Why aren't all of them moving? So, creating moving ball, 10, 100. Location. Yeah, okay, I don't know why. That's a good question. Why aren't all of them moving? You're seeing what I'm seeing, right? That only some of them are moving? That if you go to the beginning. Oh, I think I know what happened. Did I forget to delete stuff? Is that what is happening? Is my clear meshes not actually deleting everything? Is that the case? Let's see that. Let's select all. Let's go all the way to the bottom. No, it should be, because this is specifying 100 balls and we create 100, so it's going to 99. So it should be... Oh, no, 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 no. It's not doing that. Are these duplicates? Are these duplicates? It's creating duplicates. Why? Interesting. You know what? First of all, let's go ahead and delete everything. But let's try running it again. Let's try running it again. See what we get. So it seems like our clear meshes isn't actually deleting everything. So yeah, batteries are running low. I'll take care of that. So it is actually still doing the same thing. It's creating the duplicates. Huh? Why is it doing that? So what is my intuition on why it's probably doing this? Let's look at our code more carefully. So here we are creating, because before it wasn't doing this. It's doing this now. Oh, I see. I'm so silly. You see the mistake I made? I'm creating the ball, but then I'm creating a moving ball. Some of you may have caught that, but I didn't. Yeah. So let's take that out. Let's take that out. Now let's try running it. There. Okay. So now if you run this, go to the very beginning. Now we can simulate the balls moving in random direction, start and end. So, so that will actually will do it for this video. So far we were able to generate a ball, then we were able to move it, and we were generating a bunch of them moving in random. In our next part 2, we're actually going to start adding some physics logic for it to, so we make sure that balls are not colliding, and they once they collide, you know, we're simulating collision. They bounce off and they go in the direction they're supposed to go in. Okay, so that will be part 2, and yeah, that should do it.